did that happen? I wish somebody could tell me why.
I can help you with that. Okay, if I have two objects of different masses, in a vacuum, if I drop them at the same time, which will hit the ground first? The lighter one or the heavier one? So if I drop these two.
I would say the lighter one.
Water. You open the bottom. Bottom.
Same time.
So if we drop these objects of two different masses, which one's going to hit the floor first?
Lower the brightness so you'll be able to see the.
Hey, Pete!
Hi! I didn't see you there. Today we'll be looking at a common physics misconception. I want to know, if I drop two things of equal shape but different mass within a vacuum, which will hit the ground first? Now, I've specified equal shape, but that doesn't matter in a vacuum. That would only matter in a situation where there's air resistance. But let's consider the vacuum situation where there is no repulsion to the gravitational force downwards. Which will hit the ground first if this has a weight of 3 and this has a weight of 1, just units. So what we need to consider is the force going downwards. In this case, it's just going to be mg. I specified this as heavy, but it doesn't really matter at the moment. So what we have is F equals mg, where F is the weight, the force from gravity acting upon the object. We also know F equals ma. So we can compare these two and combine them to say mg equals ma. So g equals a. As you can see, the masses are completely cancelled, and the speed at which they fall will be equal regardless to the weight or the mass of the object. Now, what does that mean in real life speak? That means that a heavier object, there will be a greater force acting upon it because it is heavier, but because it is more massive, a greater force is required to accelerate it. So the increase in force acting upon it is cancelled out by the increase in force it needs to accelerate to a certain speed.
Thanks, Pete. Thanks, Pete! Go!